All right, a little experimentation. Let's play with some airflow. Let's restrict airflow and see what happens to temperatures and pressures. Well, we'll play airflow affects superheat and subcooling. So we're on recycle right now. And as you can see from the ambient air temperature sensor, we're 69 degrees. Inside the vehicle, it's 66 degrees. The evaporator temperature is 34 degrees Fahrenheit. Let me go close all the vents and see how that affects any of our numbers here for our evaporator temperature. This is a variable displacement compressor, so they act a little bit differently than fixed piston compressors. So we'll come over here and we'll shut off the airflow there. Shut off the airflow there. And there, and there. And there. Okay, I just shut off all the airflow. So the only thing I changed was airflow, and it was in recycle, so it was never even, oh, it's not warm out anyway. Only a few degrees warmer than inside. Look at our superheat. Let's see what our superheat, look at our subcooling. Wasn't this up to like 14 or so? And this was between 11 and 17, you know, it was going like back and forth. Now we reduced the airflow over the condenser. Well, imagine if we had a really plugged, and I'm going severely plugged, somebody put one of those HEPA filters in and it was really loaded up with fine dust, like somebody who was in a dusty area. Oh, like coming back from Burning Man. But now look it, it's going back up. Something is changing. And you would expect to see colder suction line because we restricted the heat load over the evaporator. So supposedly the evaporator is supposed to start freezing. But our temperature is going up with reduced airflow. That doesn't make sense, right? Because it's not a fixed piston compressor. Let's open it back up and put it on fresh air mode. And we're about 71 degrees here or so, you know, better than the 66 inside being recycled. So let's take a look back at this. There we go, our suction line temperature is taking a dive again. We're down to 36. Our fin temperature, evaporator fin temperature is 31. That's just below freezing, but it won't freeze because there is some air going over it at enough to keep it from freezing. So we'll open, 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 and put on fresh air. We are all the way up. Yes, we are. We are all the way up. Yeah, as you can see, evaporator fin temperature changed. Okay, it's jumping up, 36 degrees now. And we're going up on our superheat, and we're going up on our subcooling. And our fans, I could hear with my ears that the fan speed is ramping up a little bit. And our suction line temperature is coming up. See, as our suction line, as we have more heat load going over the evaporator, the suction line temperature is going up. Where's our fin temperature now? It's all the way up to 42. Target, the computer wants to get back down to 35. So it's going to work. Now, what it doesn't show is I cannot find the compressor control valve duty cycle. I want to see, and you see our fin temperature is coming down. So if I could look at the duty cycle of the compressor, it's hard to get to. So I'm not going to put on my little remote handheld unit on there. Too hard to get to. If I could get a display on here that I can't find of the signal pulse width modulation being thrown to the compressor control valve, you would see it's probably trying to ramp it up near 100% because it wants to achieve 35 degree fin temperature, but it's working that hard at doing it, but it's not reaching it yet. Let's give it some RPMs and let's see if we can help it out a little bit. Let's see what happens on this vehicle. Remember, some automatic vehicles that have variable displacement compressors, when you give it RPM, they actually don't go down in temperature and pressure. So let's watch our pressure, our temperature, and that's idle. So let's go about 1500 RPMs. I'm gonna hold it right there. That's all right, we're going down. Where's our pressure? Oh, I didn't hit the pressure sensor. God damn it. Did I? Temperature, passenger, air conditioning, signal. Hey, why is the signal off? It says signal on, signal off. Something's funny there. We're down to 37 degrees. See RPMs. I'm gonna go up to 2,000. 2,000 RPMs. Come on, get up there. Well, let's see. Now, if this was a fixed piston compressor, that evaporator fin temperature would be taking a dive right now. That's the funny thing about when things are automatic, software takes over. It doesn't always do what you want it to do when you want it to do it. We're getting close. And you would think with the low ambient temperature outside and no sun heat load, you would easily be able to get the fin temperature right down. Let me get back up there again. My foot fell off a little bit. I'm trying to keep it around 2,000. Okay, try that again. Barely happening here. So let's down our airflow. There we go, minimum airflow. Watch the fin temperature. There we go. We just overshot. We went below and see it went right back up. Where's our compressor on off? Why isn't it not telling us the signal? I want the signal on off signal. 30 degrees. So it's going above and below, above and below, above and below. Now, what needs to happen is I need access to the variable displacement control solenoid to manually manipulate that. And I have not been able to find that. And it's not here. I could do magnetic clutch, but I can't do anything else. All right, that's it. I'll see you guys later.